Hi everyone, welcome to our channel CodeChef. If you are interested in learning data structures and algorithms and want to improve your competitive programming, then you have come to the right place because here we weekly post videos on various programming paradigms and also conduct free live coding sessions. So please subscribe to our channel if you haven't already. And yeah, let's get started. Today we'll be solving the problem Joker and Batman, which is a simple level problem and it belongs to the July Starters. The prerequisites of the problem are hashing. Now let's go to the problem statement. The problem statement says that we'll be given colors which has ID from 1 to n. So there are n colors. And how do we identify these colors? These colors can be identified by using IDs from 1 to n. Now there will be n lists, means there will be list of colors, and in each of these lists exactly one color belongs. Means each of these lists will have unique colors. These colors will not be repeated. So these IDs will be there in these m lists from 1 to n. Now what is given is that we'll be given a strip of L colors. Now what does that mean? That there will be another strip which will have L number of colors. Now L can be any number. It can be more than n as well, because it will be a combination of different colors from 1 to n. And here in this L strip, it can be repeated also. So that is not a problem. So yeah, so we'll be given in that manner. And now what the problem wants us to find is that the Batman has lost its ability to distinguish between some pair of colors. And now which are those colors that he cannot see? So what's given here is that the Batman can distinguish colors belonging to different lists, but he cannot distinguish the colors belonging to the same list. It means that these m lists that we were having. So in these m lists, if those colors which are present in the same list, that colors the Batman cannot distinguish. But if the two colors are present in two different lists, then he can distinguish them. So now what we have to do is find the different number of segments that the Batman will see as a result of his disability. And also what's given is that the two positions of the strip are said to belong to the same segment if they are adjacent on the strip and Batman cannot distinguish their colors. It means that suppose two colors are present in this, like suppose 4, 5, 6. These three colors are present in this M1 list, and in our L strip we have 4 and 5 together. Now you see that these two colors are a part of the same list, that is M1 list. That means these two colors will not be distinguishable to the Batman's eyes, and it will form one segment that the Batman will see. Similarly, we will have different segments based on the fact that whether the Batman is able to distinguish between the colors or not. And this distinguished property means whether the Batman is able to distinguish between the colors or not is going to depend on the on which list these colors belong to. Okay, so I have explained the problem statement. Now let us take an example, a proper example, and try to understand that how this problem will work. So here I have taken n equals to 6. It means we have 6 colors from 1 to 6. The IDs of the colors will be from 1 to 6. Then m is equal to 3, means there are 3 lists to which these colors belong from 1 to 6. And you can see I have written these 3 lists here, M1, M2, M3, and there are no colors repeated in any of the lists. Each list contains one color exactly once. Now L is equals to 10. So we will have a color strip of 10 color IDs, and we have to find out now that how many segments from this color strip Batman will be able to see. Now the property that we have to use will be whether he will be able to distinguish one color from the other or not, depending on the fact that in which list those colors belong. For example, here if you see the first ID 1 of this color strip, then this one belongs to M2. So definitely like M2 only has one color. So this chef will, the batman will be able to see it distinctly. So it will be it will be one segment. Now we have 4 here. So 4 belongs to M3. Now next to 4 we have 5 here. 5 also belongs to M3. So these two colors belong to the same list. That means chef will not be able to distinguish between these two colors. So 4 and 5 will come in the same segment. Now after 5 we have 2. Now 2 belong to some other list. So 4 and 5 the chef will not be able to distinguish, but he will be able to distinguish 2 from 4 and 5. So that means it forms your second segment. Similarly, now we will go to the third color. So this third color also belongs to M1 list. That's why these two colors will not be distinguishable. So they will form another segment because this color 1 which is there after 3 is present in another list M2. So it will be distinguishable from 2 and 3. So this will form our next segment. Now 1 is simply like present in M2 and it's a single one, so this will form its own segment. Then we have 3, 6, 6. Now 3, 6 and 6 belong to the same list, that is M1. Even though 6 is present just once in M1 and here we have 6 and 6 together, but what the fact that we have to follow is that any color which belongs to the same list, even though it's present twice, thrice or any number of times, but still that will not be distinguishable to the batman's eyes. That's why all these three will not be distinguishable and they will come under the same segment. So we will divide this segment. And after 6 we have 5. So 5 is present in some other list. That is why we have divided this segment. So now you can count how many segments are there. 1, 2, 3, 4, 5, 6. There are 6 segments. So this is your answer. The batman will be able to see 6 distinguishable segments. Now that we have understood how this problem is working, how will we implement this? Well, the implementation will be very simple. Now what does the implementation actually requires? Now if you see that we are forming the segments, so how are we exactly forming the segments? We want to know that when this color ID is belonging to one of the list, and then we want to check that the next color ID which is there, it belongs to the same list or it belongs to the different list. In case it belongs to the same list, that is, for example, if we check after checking for 4, if we check for 5, then we will see that 5 is belonging to the same list as 4. Then the segment will remain the same. But now if we after 5 if we check for 2, then what's happening, that 2 belongs to a different list. So that is why this segment is being formed here. So whenever we see that a color is belonging to a different list than its previous color, in that case a new segment will be formed. This is how the implementation has to be done. It means you want to have something concrete which tells you that this color, it belongs to which list, and then you can use this number of the list to keep a check on that. So since m is equals to 3, there will be 3 lists which can be represented by using 1, 2 and 3. So you can use a data structure such that it stores that which color will be belonging to which list. Now there are certain limitations, like there is a limitation to how many colors are there, right? So you can simply the best data structure that you can use here will be an array, because it is index based, and you can take the array which is of equivalent to n. So you will easily be able to cover 1 to n colored IDs. Now these indexes of the array, it will represent the colored IDs. And what will you store in this array? So the element of each index will be that to which list that color belongs. See, like here the first color belongs to M2 list. So here we'll write 2. This 2 denotes that the color with ID 1 belongs to the second list. Now the second color belongs to M1 list, so we will write 1 here. 3 also belongs to M1 and 6 also belongs to M1. So this is how we are forming this data structure, and with the help of this data structure we will easily be able to find out how many segments are there. Now 4 and 5 belongs to third. Now we can check easily that at index position 1 it is 2. Okay, so here if we take like for example we are using the count variable, and then we will start counting. Initially it will be 0, and for the first one, so definitely like for the first color when we will check it will remain 0. Now when we will check for the second color, that is 4. So at index position 4, that is the fourth color ID belongs to the third list, which is not the same as the one which was belonging to the second list. This is different, right? 4 and 1. So that is why we will increase the count. It means another segment has been formed. Now when we go to 5, so 5 belongs to 3, which is same as the previous one. 4 was also belonging to 3, right? So this count will not increase, means the segment remains the same. Now we will go to 2. So 2 belongs to 1, which is not the same as the previous one. 5 belongs to 3, but 2 belongs to first list. So in that case, this count will increase. And similarly, we will do for each and every color, and we will keep on increasing the count whenever the the list to which the color belongs is not the same as the previous one. Then we will increase the count and we will get to our answer. So this is how the implementation has to be done. It's a pretty simple one. You just have to think a little bit to get to the answer and get to the implementation part basically. Now that we have understood the solution, let us see the input, output and constraints. So here the first line of input will be the number of test cases, that is as usual. Then we have the first three integers, that is n, m and l. So n, m and l, whatever integer it will be given in this format. Then for each m lines, so we are supposed to give these m1, m2 and m3. So the next m lines will be the list of colors, right? Now here the thing is that the first integer of the list will be the number of colors present, and then we will have the color ID. So for example, in M1 list we have 2, 3 and 6. So it will be like there are 3 colors in this M1 list. So first there will be 3 and then there will be the color IDs 2, 3 and 6. Similarly, in the second list we had just one color. So we'll write 1, that is the length of the list, and the color 1. Similarly, here we have in M3, 4 and 5. So we'll write 2 because 2 is the length of the list and the colors are 4 and 5. This is how the input will be given to us. Now the last line of input will be the L integers, that is the color IDs of the strip. So that will be this. This is the color strip that will be given to us. Now the output format, as you see here, will be a single line of answer that will tell us that how many segments the batman can see. The constraints are like 10 to the power 5 and so the constraints are okay, they are not to be worried about. Now what will be the time complexity, that we will see when we see the code. Now that you have understood everything, let's go to the code, but I seriously advise that you try to do the code on your own, because it will help you understand the concepts well. And if you are still not able to solve the problem, then please go ahead with the video. Now the code will be in C++ types. Here you can see that the first line of code are the inputs that we have. So first is the number of test cases, then n, m and l, and then we have defined int IDs n plus 1. So this is the data structure that we were talking about in the explanation, where we can store that which color belongs to which list. And I have taken n plus 1 here because I need the array to have 1 to n values, since array starts from 0 indexing, but it will be easier if we have 1 to n. So that's why I'm taking n plus 1. Now we'll run a loop from 1 to less than equals to m, because that is how the list is, right? M1, M2, M3, like we had in the example. So similarly, whatever will be m, we'll have it from 1 to m. So for each of the list, like for the next m lines of input will be each of the lists. So that is what we are doing here, just taking the input. And then in this line, what we are doing, that whatever input we have taken, like suppose the color ID is say 3. Now we will what we'll do, that at position 3 or at index 3, we will store that to which list it belongs. So if I is equals to 1, it means that the color belongs to list 1. So that is what we are doing here. We are just storing in this IDs array that to which list a particular color belongs. Now our work is very simple, right? Here we have one variable previous strip. This previous strip variable will basically store that to which list the previous color belongs, and the answer will just increment the segments as and when they are found. Now we are taking input for each of the colors in the strip, and as and when we take inputs for those colors, for each color we will check that whether to which list it belongs is the same as the color which belongs to the previous list. If it is same, then in that case the segment will not increase, and if it is not same, then in that case the segments will increase. So we'll increment answer by 1. Now what we also need to do is that we need to keep updating this previous strip. So for each color ID, we will update this previous strip with the list to which that current color belongs to, so that for the next color we can check with this previous strip. Now we'll get our answer by using this loop. So at the end we will just print our answer, and \n because we want our answers to be printed on separate lines. Now what will be the time complexity? So time complexity here, this loop will run for n times, because as you see that there are a total of n colors, and each color belongs to just one list, any one of the lists. So basically this loop will just run n times, so order of n. Then this loop you see is running l times, so order of l. So the time complexity will be order of n plus l. So guys, this was the entire problem. Now if you've understood it, then please do like the video.